Alright, let's start this out with another color. And we're going to start here. And we're going to just say, we're going to make up our own little factoring problem. Let's start out with x plus 1 times x plus 2. Very simple, very, very basic factoring problem. I'm going to make this brush size a little bigger. So if we do this naturally by the method of FOIL, first, outer, inner, last, we have x squared plus 2x plus 1x plus 2. So you can see that this is, let's change color here. First is here, and first is here. Outer is here. Outer is here. Inner is here. Inner, and last is here. So that they coordinate to be FOIL. The first, x times x is x squared. Outer, x times 2 is 2x. Inner, x times 1 is 1x. Last, the L's, x, there's no x there, it's just 2L. So, pretty easy. Either way you look at this now, if you have this problem, if you have x squared plus 3x plus 2, this is the same thing as this, just written in a different form. Well, now let's say to factor something, to break it apart from this form and to get it into that form, how do you do that? And the one way that you do that is like this. You say what multiplies to, there's an invisible 1 here. What multiplies to 2 and adds to 3? So you go multiplies to 2 and adds to 3. And when you search around in your head, you know that 2 times 1 multiplies to 2, and 2 plus 1 adds to 3. So that's how you break this apart. You break this apart by that idea. So you can see the 2 and the 1 are the factors. The 2 and the 1 are the factors that break this apart right here. Split this so that it's x squared plus 2x plus 1x plus 2. And then from there you have the form where you can work with this to get this original set of information right here. So that an x comes out of here, 1x comes out, leaving x plus 2. And the only thing that comes out of this is a 1, leaving an x plus 2. Now this looks confusing for a lot of people because it doesn't exactly look like this. It's close, but doesn't exactly look like it. What we have to do is realize that this x and this 1 come down so that it's x plus 1. And this is x plus 2. Now that seems confusing, but this is a method of factoring where this repetition is actually being factored out, as if you have two terms here. This x plus 2 is coming out to be 1x plus 2 times each one of these x plus 1s. You can imagine there even being a plus in between these here. So if you had it like, if you had just by itself 2x plus 1x. You can take by itself, you can take the x out, leaving a 2 plus 1. Right? It's a distribution of the x. So it's the distribution of the x plus 2 into this whole thing that you're taking out one time, leaving an x plus 1. So that's how you come back to this. Now, the reason that I took the time to show that is because if this gets more complicated, where if you have in front of the x squared, these usually start out with an x squared. If you have something in front of the x squared that isn't the invisible one, that it's actually a 2 or a 4 or a 3, how do you work with that? So we're going to erase this and we're going to go back and we're going to show you how to work with that.